Hi, in this short video, I will talk about the anagram algorithm analysis. One string is an anagram of another if the second string is simply a rearrangement of the first. For example, hot and earth are anagram, python and typhoon are anagram, raw and war are anagram also. Write a Python function that will take two strings and return whether they are anagram. And just to make things simple, both strings are equal length and alphabet only. How would you solve this problem? Think about this before we move on to the next slide. Okay, I'm moving on to the next slide. You can check that each character in the first string actually occur in the second. So it is possible to check off each character, then the two string must be anagram. Checking off character will be accomplished by replacing it with a special Python value none. However, since string in Python are immutable, the first step in the process would be convert the second string into a list, and then each character from the first string can be checked again, each character, the character in the list, and if found, check off by replacement. And this is what it looked like. Again, it assumed that S1 and S2 had the same length. I convert S2 into a list, starting position 1. So while position 1 less than length of S1 and still okay, I set still okay to true. This is like a Boolean loop. It's a terminate with a Boolean expression. And position 2 equals 0, so this is the second string. And for every character in position in the A list, for every character in the A list and not found, found equal to false. So and not found, I check every character in the string in position 1 with every character in the string S2. But I'm using the list in this case. If it found, then I return true, found equal true. Otherwise, I increment the next one. For example, if I have, let's just say like BIG and how about DOG, two different words. In one case, this is S1, and if I check the position starting with S1 sub 0 with every compare with every character in S2. If I find a character, then I set find to true. So if I have like a B, C, D, and D, C, B, A, I check A to D, A to C, A to B, and A to A, and I find it. And I set find equal true. If found, then I set the A list sub position to equal none. Else still okay if false. And going back, and then I set the position. Still okay equal to false, meaning not found. I did not find anything. So that will kick you out the loop. But if you find something, you just keep looking, and um, this loop here going from outer loop, and then for every character in S1, you check every character in S2. By looking at this here, you have a nested loop. So think about what is a algorithm complexity or the algorithm running time. Think about this. You should know the answer. We will go over this when we meet in class. Can you do better? It's kind of implying the algorithm is not really that good. Another solution is two words are anagram if they had the exactly the same character. So what happens if you sort them? You sort S1 and you sort S2, and then you compare them. They must have the same character if they are anagram, right? So you come up with this. In order to use sort, I convert both list into both string into a list, and then I sort them, and then I compare character by character. For example, A, B, C, D, E, and E, D, C, B, A. So when I sort them, this will become A, B, C, D, E. When I sort them, this will be A, B, C, D, E. And I compare A to A, B to B, C to C, D to D, and E to E in this example. This is what happened in the while loop. I compare each character in the same position to see if they're the same. If it is, I look at the next one. If it's not, then I know they are not anagram. As soon as I find something that doesn't match, I know they are not anagram because the sorted string is not the same. So what is the algorithm complexity here? This one is a little bit tricky. You see a single loop, but is this a linear? Is it really linear? Think about that. Computer is getting faster, so why not use a brute force approach? You can generate a list of all possible strings using the character from S1 and then see if one of them is in S2. You can try that, and it probably doesn't matter how fast your computer is. You will find you will get very disappointed result. So let's look at another approach, and kind of similar to the second approach. If an anagram of one string is an anagram of the other, then they must have the same character. But instead of compare the string, compare number of each character occurrences. For example, the anagram Earth. Let me see, Earth and what? I forgot. Earth and hot. Okay. The Earth and hot, they both had one H, one E, one A, one R, and one T. They had the same number of character, and they both had the same set of character within that. So any two anagrams will have the same number of A, same number of B, and C, etc. So in order to decide whether two strings are anagram, we just need to count number of times each character occurs. Hey, it might look like one of the homework you just did recently. So in this example, I create a list C1 and C2 and fill that list with 26 zero. Designate for count of the alphabet A to Z. So this will generate a list with 26 elements, all with 0. The 0 times 26. And then for I in range length S1, I am checking the position of S1 sub I minus all of A. So this will give me the position as in 0 to 25, 0 for A. Because if this is A, if S1 sub I, all know that is A, then the difference will be 0. And if this is Z, the difference will be 25. So it will give you 0 to 25 for the index. Because I have a 26 character, the index, if we recall, the index starts at 0. So index will go from 0 to 25. And this is what you try to do here. I mark the position and then increment that position, increment the number of occurrence for that character by 1. I do the same for S2. Find out how many occurrence for the letter found in S2. And then I compare each one. there's a 26 compare because there's a 26 letter, some of which may be 0. I compare each letter A to A, B to B to see if they have the same number of character for that letter. If it is, I increment J, which means check the next character. If it's not, still okay if false, and when I go back to the while loop, still okay if false, you will exit the loop, and you do not have an anagram if we find something that doesn't match. It will, if it match, then it will return true because you go through all 26 of them, and all 26 character have the same number of character, then you will return true. So let's look at this particular one in PyCharm. And if I run this, it will return true. So apple and orange, and I run this. Of course, they are not anagram. Apple is not anagram for orange. Given what we talk about here, so which algorithm has the best runtime performance? Think about the runtime. Uh, what is the for the last algorithm here? What is the algorithm complexity? We have basically 3 individual single loop. So what would be the algorithm complexity? And which of those algorithms, the one that I showed the code, had the best performance? In other words, run the fastest. And can you think of another way to solve this anagram detection problem? And a few weeks ago, we also looked at the memorization problem with Fibonacci program. And in that, we are using Python dictionary to remember something that already been done, so you don't have to do it again. This is another technique to improve program performance. So other than using better algorithm, you can use different technique. So let's write a is prime function that take one integer number as a parameter. It returns true if the number is a prime number, false otherwise. And after you write that function, what is a big O running time for the is prime function? And can you improve it? If you look at this program, you probably going to come up with something like this. So I'm going to write the is prime function. We had done this before. So is prime given a number is prime of say 101 is prime. 101 is a prime number, and we run this. Okay, no syntax error. So let's go back and work on the function. Prime number, a number whose only factor are 1 and itself, and 1 is not a prime number, by the way. The first prime number is 2. So if num is less than equal to 1, then there is not a prime number. And you probably come up with this loop before. For n in range 2 to num, if num mod n equal to 0, that means that's a factor, return false. It is not a prime number. I find a factor, I don't need to, I can stop right there. It's not a prime number. If I go through the whole loop and did not find anything, then this is a prime number. So let's see what would that look like. So 101 is a prime number. And let's try another one. How about is prime? How about 112? let's do one. Yeah, let's do 113. 112 is a prime number because oh, I just pick up a. How about I do 199? I know it's not prime number, just to check whether this is correct. So by looking at this here, can you tell me what is a big O running time for this version of the is prime function? Can you tell me what is a big O running time? And can you improve this is prime function to make it better than what you have? We will work out this during class to make it better.